Start.
Okay, I want to speak the first time until I say. Hi, good afternoon. We're going to start with role meeting. Okay. Okay, this meeting applied the not well. Please read carefully. I'm not going to go through this. First of all, I want to thank Emilio to Michael for his excellent job as co-chair. We have a new co-chair, Peter, so welcome.
You're very happy that Michael continues as you're very happy that Michael continues as a secretary, so I feel much safer now. Yeah.
Thank you. Okay, the meeting materials are in internet. The minute taker is Thomas, thank you very much. And the JavaScript is Diego Dujovne, thank you very much. Okay, the agenda, we are going to review the status of the working group after the draft for use. Yes. And the agenda.
I'm on notes-IETF-95-ROLL. Which is the same thing, right? It's the usual thing. Well, it's the same. Oh, really? This is just right around.
Okay. Happy?
Okay, we are going to see the use of a real information draft, and after Pascal is going to give us the routing dispatch explanation. Remotely, we are going to have Raul, and after Peter is going to explain the data model proposal, and we are going to have some discussion about the role items for recharter, if we are going to recharter, and after finally, we are going to have open floor discussion. Yeah. Yeah. Okay, some comments on the agenda? Okay. The milestones, okay, we expect to have everything done for these work items on May 2016. We are having a last call for routing dispatch draft. It is going to be extended 2 weeks more after IETF. So please read carefully and comment on the mailing list for both drafts. Okay, about the state of the interactive draft, we have some new RFCs and 4. And okay, the AMI draft, we got the security review with just some needs, and it's in the IHG. And thank you, Nancy, for the work on that. And okay, next. Okay, we have some related internet drafts that are not part of the charter, but we can include that in the future charter. Yeah. Okay, open tickets, there were items proposal that we were collecting from mailing list, and the ESC dispatch that was a claim to have the IETF header compression value. The X dispatch was a requirement. Yeah. Okay. Next slides. About this draft. Yeah, next slide. Ah. Here? No. Okay. We have a draft defining use cases. We present last IETF, and these cases have considered storing and non-storing mode of basically communication between nodes that belong to a REPL domain and nodes that are not in the REPL domain, like the internet or non-aware REPL nodes that we have like that. And for all cases, we have the combinations. Between the cases, we have 24 cases. And the rules we have some rules for these scenarios. Next slides. The rule is that we cannot modify or eliminate headers on the fly. If we want to add some fields, we have to encapsulate. Yeah, that is the rule for the scenarios. Next slide. Okay, for the cases in storing mode, basically we have 12 cases. RAF mean REPL aware leaf, no RAF, well, no REPL aware leaf. And all these cases in storing mode should have the RPI, that is the IETF95-ROLL-20160405-1620, yeah, RPL option in the hot by home header field. And like it's a storing mode, we don't need the H3, the 6554. Okay, for these cases, we will need encapsulation in which cases? In the cases that we have nodes that doesn't belong to RPL domain, following our rule previously. Okay, so the encapsulation. For example, for this case, the destination of the encapsulation. Okay, we weren't having some problems. How to know to pass the information to any story mode to, for example, from route to a node that doesn't belong to REPL. The solution that we propose is to use hop by hop encapsulation. So in this case, the encapsulation is going to end in the last syslr before going to the node that doesn't belong to REPL. So the syslr is going to remove the RPI encapsulated field and pass the information to the node. So for that one, therefore we have hop by hop encapsulation destination. In that case, no RAF to root. The destination of the encapsulation is the root. And for example, in this case, from the internet to RAF, okay, the internet, the packet arrived to the syslbr. So the syslbr encapsulate the RPI in the IPv6 header and pass the information with the destination of the RAF. And the same for the rest cases. From non-story mode to go downward, we need to specify the whole route. So we use the RH3 field, source routing header. And in some cases, we have RPI on optional, yes, because like the route is specified, we are not going to have loops. And so we will need to have RPI. And, okay. Yes, Pascal?
Pascal Thubert.
Yes.
Sorry, Ines, a quick note is if we use the 6LoRH compression, then the RPI becomes useful again, because that's how you find the root of the DODAG, which is actually used as a reference for the compression.
Okay.
So if you may, belong to multiple DODAGs, you need to know which root of which DODAG is actually used to compress everything. So you find that even if in theory you could live without the RPI, for one thing, RFC 6550 doesn't tell you can elide it. It says you should put it. And second, 6LoRH now is going to use it anyway to make sure you're compressing with the right root address.
Okay.
So let's not say we lied it, because really we won't.
Okay, thank you. We are going to modify the draft with it. Well, as well for the destination, for example, in this case, from node that doesn't belong to Ripple domain to a node that doesn't belong to Ripple domain, first encapsulation go to the root with the destination, and after to the syslr. In this case, in story mode, the syslbr has a complete knowledge of the topology. So the root knows which is the syslr that have to send the packet. We don't have this case with story mode, right? So, well, next slide. So, well, in story mode, as I say, the sender has to know which is the receiver that is not a RPL aware. And well, the solution that we propose is hop by hop encapsulation. Next slide. Okay, we add in the new version as well sys-low average compression cases. And well, the document is almost to last call. I mean, it is missing some information from sys low RH that we have some bytes to determine it still. But would be nice to have your opinion on the mailing list about this document, about the use cases. And next slide. Okay, please, comments on the mailing list on that?
I'd like to have Peter van der Stok. I'd like to invite more comments actually in a review, because it's a very complex document. I think it's very useful because actually it is quite a puzzling way to find all these ways and to see how you must encapsulate or not. And one must look carefully at it. So I would like to invite 1 or 2 reviews of this document, and that can be then sent in on the mailing list. Whom would be interested? Ooh. Yeah, this is an exciting moment. Someone who has worked on RPL before and who wants to do this, like Pasco, for example. Oh, you're not there. Oh, oh, that's a pity. Can't find them all. Oh dear. Someone else? No? Then I will try to threaten somebody later on. Okay? So, but we need those 2 reviews.
Okay, thank you very much. Please read and comments on the mailing list. Now, Pascal, please.
No, just that Michael Richardson said that we need a review from some of the implementers also.
Exactly. I would say that you don't necessarily have to review everything that's in this document. If you have to implement a particular path or you're looking at implementing a particular path, then please review at least the scenarios which involve that particular case. That's always interesting information. Okay, so 6LoRH has been around for like a year and a half. I mean, the work has been mostly done at 6Lo. 6Lo apparently is happy with it now, but since it's about compressing Ripple artifacts in data packets, 6Lo suggested that roll does the final review and goes to ASG with it. So that's what's happening now. Changes that happened in this document before actually we moved it to roll. So we have improved the documentation on how things work. There's a lot more text about how addresses are coalesced, which was kind of implicit in the document initially. So now it's much clearer. You do this step, you do this step. There are a number of stepwise operations which really detail how you do things. And we went with that to the Etsy plug test, but the document was too late. So there was only 1 implementation. So really for this Etsy plug test, we could not validate the draft that will happen in Berlin for the next IETF. Oh, no, please. Another interesting outcome of the Etsy plug test is this draft here. We found that actually with 6LoWPAN HCM, sorry, with RFC 6282, one cannot use the outer header to compress the inner header. So if you have something like a prefix which is present in the header outside, the encapsulating header, well, you cannot inherit that knowledge to compress the inside, the inner header. So considering the use cases we had with a lot of packets coming from the root and having the prefix of the root compressed with 6LoRH, we thought, oh, that would be very useful to say that the inner header is also compressed with this. Well, this inheritance does not exist in 6282. So we wrote this very small draft to say, if you're in a pure REPL world and you don't want to have to create an additional 6LoWPAN context just to reflect the same prefix that you already compressed with REPL, then why don't we create this inheritance? So if people are interested in implementing all this, please have a look at this draft 6LoW inner compression. Basically, what you get with this is that you can consider that 6LoWPAN has its own context, which is used by 6282. And in the header compression in 6LoWPAN, you indicate a context number to say where you take this state for information. Well, you can consider that now REPL is a secondary source of context, the only context being the prefix of the root. But once you have it, then you can inherit that to compress the whole frame, inner and outer header. That's what this new work brings in, thanks to the Etsy plug test, where we really discuss those things. Next slide, please. Okay, so like I said, like we all said, the 6LoRH initial draft was split in two, a piece which really deals with indexing content, which is left at 6LoW and is currently in last call. The last call review is extended, just like the 6LoRH last call review is extended, because there are not enough commands. So if you're interested in this space, please go to 6LoW. The draft is a few pages, just to say, now you can index things. But they need your review, they need your commands to pass last call. Same thing here. I know there are more implementations are coming. So please write a few words to the mailing list about the last call for this document. Next. Okay, so there are a number of issues which were discussed and addressed by this document. You will find in particular that the what was called the RH3 LORH is now called SRH LORH. There was a discrepancy between the granularity that we had above with the RPI 6LoRH and the one below with the RH3 6LoRH. So we thought to keep things consistent at the same level. Now we keep things abstract and we don't say it's specifically for RH3, we say it's for a routing header. So we call the option SRH as opposed to RH3. So there must still be in the slide somewhere to mention RH3 6LoRH, but it's now in the document, it's called SRH 6LoRH. And then I've got a number of examples of how things are compressed. The first thing that you have to consider is we wanted to make the forwarding plane easy. We wanted to enable in the REPL forwarding plane the concept of a fast path, meaning that the router has a minimum set of informations to run, a minimum messaging of the packets to operate. And as Ines has said, we have to virtually encapsulate, decapsulate, do all sorts of stuff. And if you had to do that on the real packets in the IPv6 formats as we're used to, that would be very complex moving around process. But what we did with 6LoRH is order things in a way that the code in the intermediate router now can be very fast and very simple. So officially, if you decompress things, it looks like a normal IPv6 packet, but in the compressed form, things are ordered differently so that the router operation can be very quick and very simple. Okay, so the first aspect of that, the first place where this occurs is if you have a packet which is generated by the root. So it doesn't need IP in IP encapsulation. There's just a REPL packet information in the hop-by-hop header. With the 6LRH, you basically place the RPI LRH before the IP packet. So you see that the headers have been moved from the original format. The original format, non-compressed, would be IP, then hop-by-hop option, and the rest. And you see that now the REPL option is before. Okay, but the compressed form of that is, well, the non-compressed form of that has really the hop-by-hop after the IP address. Okay, so that allows us two things. One of the things is just to process the REPL thing without looking at the rest. And the second thing that it allows us to do is keep the code that was handling the 6282 packet without a change. So you can really add this fast path operation without changing your 6282 parser. Next slide. Okay, just to show that the fragmentation as defined in 4944 is not changed. So whether you use 6LRH or not 6LRH, you can still fragment things exactly the way you did. The 6LRH, just like the IPHC, are after the fragment. So the fragmentation is independent on whether you have 6LRH or not. Next slide. Next. Basically, this is more words to say why and where we are in the final order of things. Basically, what it boils down to say is that this is an example of IP in IP encapsulation. That's the first IP in IP header. That's the second IP header. You find that we always start with the source route header. So because when you have to route this packet, what you really need to do is pop the first entry, the first next hop in this routing header. So by placing this first, it makes the forwarding plane easy. You just have to move forward by one. Okay, on this header. And then when you're done with all the outer IP, then you just truncate everything and you continue. So the fast path processing of this packet is actually very simple, even if in theory the non-compressed format is the same as usual. Okay. Next. And then I'm giving more examples of that. So just a small remark is if we are using this new draft, this inner compression draft, then the inner header here can inherit the prefix from the outer header. That's what I was trying to say earlier. If you don't do this new draft, then you have to have one, a REPL context based on the root, and two, a 6-LOPAN context, which will have the exact same prefix. And you will have to distribute both. REPL distributes the roots with the DIOs, and through arrays will distribute the 6-LOPAN context. Distributing the two of them for a single result seems like an overkill. So that's why we introduced this inner header thing. And we're pretty there. So thanks, Michael. Thanks a lot for being the shepherd for this work. And guys, please comment on the mailing list on all was said today and on the draft so that we can conclude the last call and go for Berlin for interrupt test. Thank you.
Thank you, Pascal. So we're really looking forward for other comments. Yes.
So Thomas Watena, just to let you know about the plug test in Berlin that will take place right before the IETF meeting. I think the dates are 16, 17, I believe that's July. And so this will most probably, I cannot say it definitely because we haven't formed a group yet, but is most probably going to be one of the things that are tested. So we're going to do this. So if you're interested, contact us and participate in the plug test. Thank you.
Okay. Well, it would be nice if people read the drafts before they start the implementations. So I would really encourage them that in the coming 2 weeks, while we still have the working group last call, that they send in their comments and or at least show their interest and send in comments like we have seen it. There has already been extensive discussion about this draft in the 6LO working group, and before there have been much internal communication. So I believe that it's actually satisfied the requirements, but it will be nice to hear from everybody that they have read it and approve it. Thank you.
Do we have reviewer for this document? Someone want to review the document? Pascal? Doctor? Yes.
Just want to tell you real quick, Michael is sitting on the queue. I think he probably has a question for Pascal.
Hi,
Hi.
Michael.
Hi. So, Pascal, one of the things I would wonder if you could speculate for us is there a cost in 6LoW-RH for the fact that we have to remove that RPI before we get to the non-RPL node? Would 6LoW-RH be would there be any efficiencies if we would make the option type change in the thing? Can you speculate on that?
I can give you one speculation, Michael. It's for the time being, I would expect that a non-ripple aware leaf, or whatever we call that, a plain host, if it gets a packet with a 6LoW-RH, it would be very surprised because it has no support whatsoever of 6LoW-RH, meaning that it would probably die or drop the packet, do something wrong. So that would not help much whether we call it droppable or not droppable. Because just to give some context, maybe for the room on this discussion, there is a discussion at 6man, and probably I had some slides somewhere about that. There's a discussion at 6man about the death of hop-by-hop header. And you know, Ripple is using heavily hop-by-hop header, so if it's being deprecated or slow death, that might be an issue for us. And one of the proposals on the table is really to say, oh, well, the routers are allowed to ignore it, whatever the setting of the first 2 bits in the option, which really normally would tell whether what the operation should be. In IPv6, the first 2 bits of a destination header, of a hop-by-hop header, and option headers basically tell you, if you don't know, well, leave it alone, just skip. If you don't know, drop it. And right now, the hop-by-hop header in the option value that we picked for the Ripple option says, if you don't know it, drop it. Which means that if we send the non-compressed form of this to a normal host, it would probably drop the packet. So the proposal on the table to help us here is to say, oh, we go from 63 to 43, meaning that we reset this bit. Meaning that if you see this hop-by-hop header and you don't understand it, well, you should ignore it, which would be nice for us if we want to that's Michael's point, right? If we want to support non-Ripple aware host, that would be true, Michael, in the non-compressed form. But in the compressed form, you still need support for 6LoW-RH by the device, which, and because 6LoW-RH right now is mostly for Ripple, that really means that the device supports.
Right. But the point is that we are doing some effort to be able to essentially say that we are doing encapsulation and decapsulation in IP headers on a hop-by-hop basis, which changes the addresses on the outside that we're putting in, which may make them less compressible, which is one concern I have, such that we can remove, if necessary, if you've pointed out, we can remove all of the compression and we can deliver the packet to an end host that does not speak 6LoW-RH or Ripple,
Yes.
and we can do that. But if we didn't have to officially have that IP header there, we wouldn't have to compress it, and we could just deliver a packet directly to the end host with the RPI still there.
Yes, I mean, we could leave it. I mean, that's the question is really for the last 6LR, knowing whether it should remove it or not, which is because leaving it or removing it is not so complex. The question is to know whether you have to do it or not, because you don't know what kind of device you have to deliver the packet to, that's really the problem that we have in this space. All I'm saying is the way it's formatted right now, the packet from the root with just an RPI is formatted like you've got the 6LoW-RH with the RPI, easy to remove, and then what comes after is the 6282 packet the way a plain host expects it. So that's really the design point. Now, the decision of leaving it or not leaving it is kind of orthogonal. It's just easy to remove it. That's the only design point. But I'm not saying when to.
But I am still concerned about the compression of that outer IP header, particularly in the not fast path case, where, for instance, we are obligated to generate an ICMP from that last host to, say, for instance, host unreachable, which we would then send to the previous hop, which would be meaningless to send it to the previous hop, right? Okay,
Yes,
so
so you-
there's a bunch of stuff there that we're doing to keep that IP header intact because of the six-man rules about adding and subtracting headers. So there's a bunch of stuff that we're doing so that we are able to reconstruct the uncompressed packet and in such a way that it's addressed to that host so that we can remove the RPI. Right?
Yes,
We're doing
so
that stuff to do that. So the question is, if we didn't have to be so careful, would we be able to compress better?
I don't see that we would be able to compress better. I see that we would be able to leave it would be easier to encapsulate because you would be able to say what's the node which will decapsulate. That would be the final destination. Right now, our problem is we need to be able to indicate that the 6LR that serves this final destination is the one that should decapsulate. And we don't know how to do that. So that would simplify our life at the encapsulation time, but I don't see how the compression would be better. So for me, it's kind of not to 6LR. It's more the policy, how we decide to do what. It's a routing problem, it's a architecture problem, but it's the compression just serves the need that you have, and you can compress what you want.
Okay, so I'm just trying to figure out what the case for changing the type code is. If the result is 2 byte savings on every hop, then that would seem to be a really big argument for why we should change it immediately, because we have with this document, we have essentially a flag day, right? There are, we do not propose at this point any kind of signaling to say we support this new protocol or we don't. It's going to be the operator network installer who either turns this on because all the devices support it or leaves it off because some devices don't support it, right? So we have an opportunity for a flag day here.
Yeah, I mean, the only value I see is to enable the source of the packet to encapsulate down to the destination, right? So we keep IP down to the destination. It has nothing to do with compression, really. It has to do with being able to solve a problem that we don't know how to solve otherwise, or we've got this weird hop-by-hop operation, but it's really weird. And really even weird. If we do that, the last 6LR has to know is this last 6LR, and it should not redo this IP and IP. So basically, it's a much cleaner design to be able to say, I'm doing IP and IP to the final destination. And the only reason why we could not do that, it's because of this code in the hop-by-hop header.
The time is slowly passing.
Thanks.
Thanks very much. Could you continue it on the mailing list, please?
Okay, we should have remotely, Raul.
Hello.
Yeah.
Hello, I hope everyone can hear me okay. All right, so I'll just start. So the draft talks about the NOPAD DAO problems. The draft specifically states the problem statement is, hello?
Hello?
Yes?
Where, please? Thank you.
Yeah, is it okay? Am I audible enough? No.
Yes, it's okay.
All right, okay. So NOPAD DAO, just a little recap on what NOPAD DAO is. The NOPAD DAO is essentially a DAO with a lifetime of 0. It's used for route invalidation. A child node, when it switches the parent node, it sends a NOPAD DAO via its old previous path, and a regular DAO via its new path. So it traverses, in all the cases, all the DAOs, likewise the regular DAO, the NP DAO also traverses upwards along the topology in the upstream direction. So why NOPAD DAO might be important for us? So as you might have already know that routing entries are the biggest memory hogging component, especially in the bigger storing mode RPM networks. So thus, if there is a contention, it will be nice for the routers to know which of the entries are non-active and can be removed or can be replaced with. That's when another important point here is when the node switches a parent, it's not only that node which switches the parent, but it's the complete dependent node. all the other dependent nodes along beneath that child node also switches the parent. So it's kind of lot of changes that happens to the routing tables, especially when even a single node switches parents from one upstream parent to another. Then there is an impact on P2P traffic. I'll come there in the subsequent slides. And can you please go on to the next hour? So this is the sample topology I'm considering. Let's, for the sake of this discussion, consider this topology. Node D might switch from parent B to C for certain reasons such as transient or permanent link failure. Another reason would be that D finds a better parent in the form of C, which satisfies better, which has better metrics as compared to its previous path through B. Can you
hold your mic a bit higher, maybe?
Hello? You want me to hold the mic a little bit far off? Hello?
A bit closer the mic, please.
Yeah. Is it okay?
Yeah.
Yeah. All right. So this is the sample topology that I'm considering here. All right. So these are the cases that I've highlighted where node B switches from node D switches from node B to C for various reasons such as link breakages because of transient or permanent link failures, or a simple reason such that either the metric from the previous parent has went bad and there is an alternative path available through C. So this is another reason why NPDAO can be generated. In all the cases, currently the NPDAO can be generated through the previous path. The node D has the responsibility of sending the NPDAO via its previous path. So what are the problems that we might face because of this arrangement? So the next slide talks about it. Can you go on to the next slide? So this essentially is the list of problems that are associated with the NPDAO mechanism currently specified in the RPL specifications. So the first biggest problem is the NPDAO messaging depends on the link which the node had decided to no longer use because of whatever reason. Especially if the reason is because of the link failure, then the NPDAO messaging will definitely suffer. It's a guaranteed failure of NPDAO messaging there. Another important point, the point number 2 here, is that route invalidation happens only for the node who generates NPDAO message. Now there are dependent nodes on behalf of whom there is no NPDAO which is generated altogether. So on the previous path, there is no way of generating of route invalidation along the previous path. Yeah.
Excuse me, Rahul.
Yes.
Pascal Thubert here. Normally, you're expected to keep. So first, I mean, it was not mentioned, but this is all about storing mode. So we're talking about triple storing mode when nodes keep track of the routes on their subtree or subtag. Second is in this table that you maintain, you basically, it's a distance vector, you expect to know who is behind each of your children, right? I've got this child, and through this child, I can reach this subtag.
Correct.
And because you know this child to the rest of the world relationship, if you lose your connectivity to that particular child, then you know that this child is lost for you, but you also know that if he was the only way to get to all this subtag, then all the nodes in this subtag are lost as well. So you're entitled to send a NodeAO to all of them. I call it NodeAO, it's an NPDAO.
Yeah, all right. So essentially what you're saying here, Pastor, is let me just recap. You're saying that there is a possibility that node B knows that that the child D is not available, right? Considering the topology shown in the... Hello?
Hard to hear you.
Sorry, can
I'm
you
just saying, the subtag, know the subtag that you lose, because if you know you lose a child, then because you've got the route via this child to all the rest of the subtag, then you also know that you lose this subtag, so you can send a no-path DAO for all the children of your children, for all the family, if you like. So it's all the guys on the bottom of your drawing, they will get a NodeAO if this guy moves from left to right.
You're saying Can you quote with an example here? I mean, if I've understood it correctly,
There
the
was
question.
I see the code, but I don't see the names from where I am. I mean, there is ABCD, but I don't see them from where I am. Let me.
Okay.
Okay, so you seem to be saying that there is, if D goes away from B, okay, D goes away from B, so this is broken. So I understand you were saying that there is no path DAO for E or for F.
Correct.
And I'm saying there is, because B has a route to E via D, and he has a route to F via D, and that's the only way he knows how to get there. So if he loses the route to D, he will also lose the route to E and to F. So he's entitled to send a no-path DAO for D, for E, and for F.
No,
That's
first,
what I'm.
yeah. First, here the assumption is that the no-path DAO has actually reached from the previous path. So the first point here takes care of. I mean, suggests the problem that the NP DAO itself might not reach in all the cases. I mean, along the previous path, there is a possibility that NP DAO might not reach at all because of the permanent link failure. Let's say, for example, let's take the scenario of permanent link failure. So there is a chance that NP DAO might not reach at all. So there is a guaranteed not working of NP DAO might not work in a guaranteed way if there is a permanent link failure along the previous path. If you're saying if there is an alternative way of G realizing that there is a link breakage, then it can generate. So there's in the subsequent slide, I'll just talk about what are the problems that all the other nodes there is a problem in the sense that another node cannot generate no part DAO on behalf of the target node. So especially because there is a dependency in terms of state information such as DAO sequence. So it's I mean there is a sentence, there is a line, there is a statement mentioned in the RPL spec which talks about sending a packet to invalidate the routes and clear the RPL state. But it is easier said than done, especially because every DAO has a state information. So I'll just continue with the presentation.
There's still very little time left. Can you conclude?
Yeah, here, let me just go on to the previous slide. I just want to highlight the problems, the other problems as well. So can you please go on to the previous slide?
I can't hear.
Can we please move on to the previous slide again? Yeah. So here, the other problems that are mentioned is the possibility of route downtime because of the asynchronous operations of NP DAO and DAO. So NP DAO is sent through another path and DAO is sent through another path. So there is a possibility that NP DAO actually reaches and DAO never reaches, because even though the node has sent the DAO, there is no guarantee that DAO might actually reach the border router. So there is a possibility that because of this asynchronous mode of operation, that there is a downtime. Secondly, in terms of let's assume for the sake of discussion that there is no way of clearing the routing table if there is no NP DAO reaching the previous path, in which case there is an impact on P2P traffic. The example, the point number 4 here shows an example. If J originates a traffic for E and F, and if G has invalidated invalid routes, then it will cause traffic failure.
Okay. Thank you, Raoul. I think I want to conclude because the communication is not really optimal and also the time is going on, if you don't mind.
Okay.
Can we maybe conclude and then continue this discussion?
Sure. Maybe I can just, the point that I wanted to make is from the requirements point of view, what can be an optimal solution for an NP DAO problem statement? So the next couple of slides talks about the possible existing solutions which were discussed on the mailing list, thanks to Sankan Simon. And then maybe on, this particular slide talks about some specific scenario that can be handled, using DAO-ACK mechanism. There is an optional DAO-ACK mechanism already present as part of RPL signaling. From the requirements point of view, yeah, this can be the final slide. Can you please move on to the requirements slide, previous slide, please? No, previous slide, requirement slide.
Okay.
Yeah, this one. So from the requirements point of view, if you see, the NPDAO messaging should be tolerant to link failures to the previous parent. It should be possible to invalidate routes for dependent nodes as well in a more concrete way, rather than depending upon some mechanism such as neighbor discovery to fail and such. So network formation is handled by RPL. The route formation is handled by RPL. The route invalidation also can be handled concretely by RPL. Ripple. Secondly, the route downtime. It should be possible from the requirements point of view to avoid route downtime for NPDAO because of NPDAO and DAO operation. So this is from the requirements point of view. Yeah, that's all I have to say.
Okay, very good. Thank you very much. I hope you will continue this discussion to get the problem clear on the mailing list, and then
Yes.
later on we will see how solutions can be put forward. Thank you very much.
Thank you very much.
Okay, now Peter is going to present data model for MPL.
Okay. This is quite a new subject. It is something which has been an old wish in the ROLL working group, that there will be a management and an MEB to define the parameters and to look at the operation of MIPL and RIPL. So what we have done now is that we didn't make a MIP in the SMILE language, but we have used YANG, which is a more convenient language here, to describe the model. So what I want to do here is just describe the model and see if there is any interest that we continue this work in this working group. I have separated the model in 4 parts, as far as I remember. One is about how the multicast addresses span up a domain, because MIPL knows domains which are spanned up by multicast addresses. Next slide, please. Then I have a set of operational parameters, which are the setting actually of the MIPL, such as the lifetime, the domain 8, the emin and the emax, which are the operational parameters used to start the MIPL operation. I have a next section. That is the actual execution of the MIPLs per seed and in the domain, so that while you look at it, you can see how the parameters perform. For example, here you have the current interval, the C counter, how many packets has arrived, and the T that the next packet has to be sent. Next slide. And then finally, the statistics, which give you from how many messages have been received, forwarded, rejected, not received, etc. So these are the 4 parts. I would welcome some comments on the mailing list, because the domain is rather complex with lots of arrays. And you may say that for a small device, that's not wanted at all. And that, for example, the domain definition is too complex, or that you say the different items, they must be separated, and you can do actually determine if you want an item in a node or not. So that were the several questions. My question, is there any interest to continue this work here? No. No. Yes. Oh, thank you. It was not a no. Another yes. Oh, good. More yeses.
Or yes?
Yes. Good.
Great.
Fine.
Great.
And is there a no?
Yes. Okay.
No nos? No. Okay. Thank you.
Thank you. Okay, now we are going to talk about the recharter, in case that we go through that, and we have to define like some topics to work on. Would be nice to have fixed topics, like if we have already documents that are interesting for the working group, would be nice to integrate it as recharter.
Oh. Technical, huh?
Okay, we have.
No comment.
Okay. Okay, we have like some items for maintenance the protocols, like, well, proposed from Raul. We have as well some other draft that we don't have so much mails about this modification. So it would be nice if you can review the not working group draft and send your comments. And Pascal, or your DAO projection, do you want, like, we have some story mode in non-storing? You want to say something about this? Are you?
I don't think that the DAO projection qualifies as maintenance. It's a new work. It's really taking Ripple in the SDN world. So that I think that's interesting enough to make it a standalone point.
Okay. Do you agree with this? What do you think? What do you think? Do we want to work on that? Okay, that silence means yes or no?
That's we don't know. Okay, let me be. Is there anybody else who has read the past DOO draft from Pascal? Yeah, very good. So there's interest, and we want to continue that work. Yes. Yeah, for me as well. Yeah, I thought it was interesting. Yeah. Other people are interested. Then the automatic selection. Okay, this is another point which came from me. If you look at the Mipple and you have a very dense network with lots of Mipple forwarders, then what you get are much too many packets which are sent, so you get no progress almost. So what I propose is that there's an automatic selection of Mipple forwarders dependent on the density of the network, so that you reduce the number of Mipple forwarders and you have a possibly minimum number of Mipple forwarders. Is there anyone interested in continuing in that work, or think it is positive to work on that? I certainly wanted to start it, but if there is no interest in it, no. It's a nice mathematical problem. And very satisfying when it works, of course. No, okay. Yep.
So I think at some point we're going to go down this road.
Mm-hmm.
We probably want to look at something.
So, okay, so in general, looking at how we could improve the multicast, we'll enter in that work then. Okay. Are there other people interested in multicast work in this context? No? So, okay. So that's 4 people. Oh, that's interesting. 5. Fine, great. So we already looked at the data models for Ripple and Mipple, and I thought that there was sufficient interest to at least continue it. Okay, you want to say something about your source routed multicast, Karsten?
Thank you. I better not touch it. 3 IETFs ago, I had a short presentation, I think at 6low, on this idea of using Ripple for source-routed multicast. This is essentially taking the ideas of the beer group and applying them to constrained environments. So I haven't asked for presentation time here because time is short. So you can look up the slides from a year ago. And this has been implemented, some simulations have been run, and so on. So it generally seems to work. And if we want to have some low latency multicast, that may be a way to do that. but it certainly would benefit from more people looking at it.
Please, when you do such a thing, it will be nice if it will be compared by a performance comparison with others, such that you know at least when to apply, because having all those multicaster algorithms around and not knowing when to apply it is not the best of things.
But it's not just the performance issues, it's also an issue what roles do you give the nodes in the network. So Mipple makes relatively high requirements on all the non-root routers in the network. This constraint cast really is non-storing mode. So everybody else but the root has no idea what's going on and just forwards packets according to what's in the packet.
Pascal Tumer. For one thing, I support this work, and the other thing is it seems tainted or flagged multicast, but the use of beer for Ripple can be of interest for unicast as well as multicast. And the value would be a better compression of what we are doing even for unicast, simplification of what you put in the DAO. You just, with a simple bitmap, you can aggregate all the DAO routes. And that basically gives us, with a limited state, the capability to do storing mode in modes which would not be capable of doing storing mode if they had to store the full addresses. So you would basically express each router with a bit. So not only is this very interesting, the work that Carsten is proposing us, but the fact of using beer in Ripple, I think, is of high interest.
Thank you, Pascal. Diego?
Yes, Michael Richardson said that if it's cool for root-initiated multicast, can we use it for firmware updates? Yes, that it's, he says that this is cool for root-initiated multicast. He asks, can we use it for firmware updates? Yes.
That's an application question, and it depends what kind of software you have in your device to do this firmware update. So, in principle, yes.
So using IDs from beer for these networks, I think, is very interesting as well for doing replication and increasing reliability. So I support this work.
Thank you, Thomas.
Carsten Bormann, I hope I'm not jumping the gun here, but there's a lot of interest in working on firmware updates in the IETF and the IETF right now. So stay tuned. There will be an announcement soon.
Thank you, Carsten. So we have 3 minutes left. Some other comments? Well, there was a presentation yesterday at 60CH. I think people there is in the area still about EODV and Ripple. There was a mailing list, so please read the draft and send your comments in the mailing list. Any other business? Yeah. Okay.
So anyway, many thanks for the comments on the topics for the possible recharter. So we will propose that again in Berlin and then see what the charter may look like. Okay.
And please, for the new ones that came late, review the draft from Routing Dispatch, paging from Syslow, and the use of RPL info. Please, we need your comments and reviews. Thank you very much. Okay, we are done. Thank you very much.
Interior. Most of the time listening to Charlie's presentation.
Oh, well, I was elsewhere most of the time too. I just came in here for the very last thing.